right, I have one more video I want to share with you, and I want to touch base on angular momentum. Because there are three conservation laws that we focus on: conservation of energy, conservation of linear momentum, and conservation of angular momentum. So we have learned that the moment of inertia is I, and that angular velocity is omega. Regular momentum is mass times velocity. Angular momentum is the same equation, but with the rotational equivalence, I omega. It's measured in kilograms times meters squared over seconds, or kilograms meters per second times meter. So it's also measured just like we measure any momentum. And if we use a little bit of algebra, then if we plug in for omega, which is omega, if we plug in, for I, we get Rm times V. And so you can see that it is related to regular momentum, P. Angular momentum is a vector, just like rotational, just like linear momentum. And I think what I want to do here is I just really want to concentrate on this conceptually. The angular momentum, I times omega, remains constant. So let's take the skater, or in this example, a person on a stool rotating around. When his arms are outstretched, he has a very large I and a small rotational speed because he's got a lot of inertia. It's hard to rotate him. When he pulls his arms in, he changes his rotational inertia so that it is smaller and he rotates faster. This is a direct result that the total momentum of a system stays the same unless an outside, in this case torque, acts on it. So if we just consider this person, when he pulls in his arms, the quantity I times omega has to stay the same. If he makes I smaller, then omega has to get bigger. So as the moment of inertia decreases, the angular speed increases, and so does the angular momentum. So there is a video that I would like you to take time to watch, and it explains something, a phenomenon.
You need a website. Why not do it yourself?
And that is why cats land on their feet. So we are going to watch this together, and hopefully you'll learn something. And I'll try to make it a little bit bigger here so that we can see it.
Hey, it's me, Destin. Welcome back to Smarter Every Day. So you've probably observed that cats almost always land on their feet. Today's question is why? Like most simple questions, there's a very complex answer. For instance, let me reword this question. How does a cat go from feet up to feet down in a falling reference frame without violating the conservation of angular momentum? Now, I've studied free-falling bodies, my own in fact, in several different environments, and once I get my angular rotation started in one direction, I can't stop it. Today, we're going to use a high-speed camera. We're not going to use Allie because this is my daughter's cat. I don't want to hurt it. We're going to use a stunt cat. Let me introduce you to Gigi, the stunt cat. I'll just flip the video vertical and then motion track the cat. It's just going to take a lot more effort in post. We're going to try to do it in a way that doesn't make anybody mad. That's pretty hard to do. You got to drop a cat. Ready, Gigi? Good. Checking out the high-speed data there, Gigi? Okay, the first thing a cat does when it's falling is try to figure out which way is up. It does this either with the gyro in the ear or with its eyes. 3, 2. Ready to talk cat physics? Alright, so check out this footage I captured with the Phantom Miro while Gigi goes to get a drink of water. So here's what's interesting about this to me. If you'll notice at the beginning of the drop, the cat is not rotating. Halfway through the drop, the cat is rotating, and then at the very end, Gigi somehow stops rotating. Newton's first law says that an object at rest will stay at rest unless acted on by an external force. I see no external forces on this cat. So what's happening here? It's not making sense to me. Okay, so in order to really get the right data, we're gonna have to drop her 90 degrees out of phase. Ready, girl? This time watch your tail. 3, 2, 1. Okay, so you think you figured it out? Check this out. You probably noticed that when the cat was falling, her tail was rotating in the direction opposite of where her body was rotating. What's interesting about that is that that's not how it works. In fact, even bobtail cats can do this. It's called the cat riding reflex. I'll prove it to you. I came across some video from the 60s when the Air Force was researching microgravity for future astronauts. Turns out they took some cats up on parabolic flights. He tries to rotate his tail to flip over, but it doesn't work. He just ends up nutating wildly. Then he does something interesting. He takes his back and he bends it. And when he bends his back and then creates motion, something interesting happens. Ah, now we're getting somewhere. So let me show you one more cat flip with the Miro and we'll figure this out.
Here goes.
Okay, the arched back ends up being pretty important. What he does is he divides his body up into two separate rotational axes that are tilted from one another. When he's released, he pulls his front paws in and does the ice skater trick. He decreases his moment of inertia in the front so he can spin fast up there. But in the back, he pushes his legs away from him, increasing his moment of inertia. So a really large twist in the front equals a really small twist in the back in the opposite direction, and the torques equal out. So as soon as he gets his front paws in under him, all he has to do is extend those legs back out to increase that moment of inertia and stop the front twist, and extend his back legs along that rear axis. That allows him to twist those around really fast, and then all he has to do is pull them back in under his body and then extend all four legs and brace for impact. So thank you for your attention. I hope you learned something pretty cool about cats. If you don't mind, woo! Okay, I'm done. If you would, go check out your other cat videos after trying to catch Gigi. Woo! A little too rowdy. If you'd like to, click Gigi the cat to subscribe. We'd appreciate it. I hope you had a good one. And go get the ball. You gotta catch her first. I got it. You want it? Look. Very cool cat. She let us drop her hundreds of times. Or, maybe just 5. Want your ball? Go get it! Click her if you want to subscribe. Oh! But right now we're playing fetch. Right? Go get it!
Okay, so I
I'm
like that
Destin.
video.
You get smarter every day. Have a good one.
I hope that it doesn't offend anybody and that, you don't get too upset. But, the website is posted in your PowerPoint here so you can contact them because I didn't drop the cats. He did. But it's interesting application. It explains a lot, and I suggest that you go search YouTube for cats that have, jumped off of incredibly high heights, and if you watch those videos, you'll see they do exactly the same thing every single time. Pretty cool application of something that's pretty geeky, right? So physics is fun, guys, PHUN, and that's all I'm going to talk about this semester. So if you're taking Physics 152, I'll be glad to see you and work with you then. If not, hasta la vista, baby.